So this is a project I'm working on to create a smart lock sort of assembly. So the way that this works is that I have a deadbolt here. This is all one deadbolt, I guess, assembly or cylinder. It has the arm to open and close the deadbolt lock, and then it has the servo on top, which has arms coming out at the bottom here, where the motor inside is connected, and then it's duct taped to the handle for the deadbolt. And then it is secured to the actual frame of the deadbolt with these two of these 3-inch long, 1/8 inch diameter bolts, which are duct taped to each other and then duct taped around the frame of the deadbolt. And then that's actually almost it for the construction of this. And then out from the servo comes this PWM connector, which I have 3 jumper wires plugged into. And so if we plug these in, let's take the red wire, which is for the 5 volts. So I'll plug that in. We'll take the ground and plug that into the adjacent ground. And then we'll take the final wire for the signal, which is how you talk to the servo. And we'll plug that into the port that I have assigned, which is port 12. There we go. You can hear the buzzing of the servo. That's a problem with Arduino's implementation of the servo library, which eventually will get fixed, so it doesn't make that annoying buzzing sound. So the way that this works is that the Arduino is plugged in through USB to my computer over there, and then I will write some Arduino code, C code, to interface with the Arduino and essentially the servo. So you essentially have a servo which is attached to some specific pin. I chose pin 12. And you define what are the range of motions for the servo. So I said the lock state will be at degree 0, and the unlock state will be at degree 120. And then essentially after that, you just have it in some sort of loop where it looks for serial data, which is sent over the USB. And in my case, I have it checking for the letter V being sent. And if it is sent, it'll swap to whatever is the opposite position. So if it's at 120 degrees, it'll swap to 0 and vice versa. And then a delay for 3 seconds. And the way that I'm connecting over serial is done through this Python module called PySerial. So I essentially will establish a connection using PySerial to the USB device, which is the Arduino. So I'll create that, and then I can write the letter V to or over the serial connection. And so let's reset the servo, and it might actually move for us. Nope. All right. So let's write the letter V. So wrote the letter V, and it swapped. So let's do it again. And it swapped back. So it'll open and close, sort of just swap in between, since there's nothing really else it can do. And yeah, so it's actually a sort of working implementation of the idea that I had earlier today. Scrambled for parts to find it, and I got it working. So there's a few problems with this. Firstly, that it's very, very specific to this deadbolt handle. So the whole plan is that the final assembly will be able to fit over any existing deadbolt and have some sort of mechanism to latch on to the handle and rotate back and forth. It's not a catch-all, but it should fit many different types of deadbolts. As I imagine, they all have handles that are similar to this, and so as long as you can catch onto one side, you can rotate and open and close. The other problem is that if you noticed, when the servo rotates the handle, it actually will rotate with it a little bit. And that's mostly because I'm pretty sure that there's only one point of connection here, even though it's 2 bolts. It's really only one point connecting the servo to the cylinder. And so as the arm moves, it's almost free to move. So if you watch, you can clearly see that the servo is moving. So that's a big problem. It's a lot better than the first attempt I had at building this, which was an even bigger mess of duct tape and even more inconsistency in trying to open and close. But I've now almost fixed it. So doing this for a while, I can open and close it. It's very entertaining. And eventually I'm going to try and have the Arduino be connected over Wi-Fi to some internet source, and that I should be able to have some sort of Flask web server implementation, and I can create like an API to interface with the Arduino, which will then allow me to interface with these servo. And so I can open and close the lock remotely, which is nice because then you can extend that to things like phone apps. So I could control this from my phone, so I can tap a button and it would lock my door. Or like Alexa, I could say, Alexa, unlock the door, and it would unlock the door. Hopefully not from the outside. So I feel like there's a lot of opportunity with this, and the main advantage is that I feel like I can build this for cheaper than can currently be bought on Amazon. Since a lot of versions on there cost anywhere from $120 to $230, and I feel like that's very overkill. Even if I'm using an Arduino, which is probably overkill, I think this can be done for cheaper. So that's what my goal is. This is the first prototype of it. I love that. Okay, so thanks for watching. See you later.